So the Pythagorean theorem only applies to right triangles, and when we say a right triangle here, what we're really referring to is a 90-degree angle. Now, of course, there can only be one 90-degree angle in a triangle. I said, of course, making a huge assumption. If you didn't know that, don't worry about it. But this little mark right here in a triangle, if it's shown, then you know that it's 90 degrees. Now, for the sake of this particular section of this module, sometimes they may not actually show that, right there, okay? But since this is the Pythagorean theorem, remember, it only applies to right triangles. So even if they don't show that mark, we're going to make the assumption that it should be there so that we know that we are dealing with a right triangle, okay? Now, right triangles are unique. And so, well, to math people, they're unique. So we gave names to the side lengths of a triangle that is a right triangle. And yeah, of course, we had to name the triangle. So naturally, we have to name the parts of the triangle so that we know what we're talking about. So the two legs right here, as we saw there, remember this little mark right there? These are what we call legs. The two sides lengths that make up the right angle, the 90-degree angle there, are what we call the legs. The other side is called the hypotenuse. And if you have trouble remembering the hypotenuse, I don't really care if you know how to spell it, but if you have trouble remembering the hypotenuse, just there's a Key and Peele skit on it, and you can watch it. It's great. Okay, but the Pythagorean theorem will only apply as long as we're dealing with right triangles like this. But you're going to hear in this section, I'll always refer to side lengths as legs and hypotenuse, most of the time at least, okay? So hypotenuse is the side opposite of the right angle. We call that opposite. It's kind of, I think of it kind of like it's pointing at the hypotenuse. And just kind of as a little factoid, hypotenuse is the longest side of a right triangle. Not that I think you care. I think if you're ever on Jeopardy and they're like, hey, whatever's the long side of a right triangle, now you know, okay? Now, the Pythagorean theorem. This is the Pythagorean theorem right here, kind of, okay? So the Pythagorean theorem is, it's more of a conditional statement. It's a if you have a right triangle, then you have this relationship with the legs and the hypotenuse, okay? Leg squared plus leg squared equals hypotenuse squared. And if we really wanted to go the distance to make this abstract and sound really nerdy, because if you said leg squared plus leg squared, people would be like, what the crap are you talking about? But the moment you make this a squared plus b squared equals c squared, they're like, oh, now it's Einstein kind of stuff, you know what I'm saying? But it's just leg squared plus leg squared equals hypotenuse squared. That's really the way that I like to look at it. And for these problems, we're going to be using principles of equality to solve, just like we saw on that last section. Of course, since we're dealing with exponents of 2 on this, we're going to expect to see some of these relationships solved with square roots. Oh, so the Pythagorean theorem, it comes from ancient Greece. Yes, the Egyptians had it before the Greeks, but the Greeks made it famous through Pythagoras, who was a Greek dude. He was like the king nerd of the time. Like, I don't know if that's a good title or a bad title, but like they would have parties back in those days, and they'd say, you know, they'd put up flyers on light posts and stuff, saying, come to our party, we're going to do some math. And people would actually show up, like, what the crap is going on here, right? But they didn't have Xboxes or PlayStation, so I guess that kind of makes sense. But they would get together, and they would eat triangle-shaped sandwiches and do Pythagorean theorem all day long. Ironically, Pythagoras murdered a dude because they had a disagreement. And history, at least history these days, shows that Pythagoras was wrong. So he killed a guy and was wrong, but whatever. It was high stakes back in those days. You couldn't be wrong about stuff like that because you'd lose your job, I guess. But yeah, that shows you what can happen when a group becomes too powerful. They're all dead. All right, find the length of the hypotenuse. Find the length of the hypotenuse of the right triangle pictured below. Round the answer to the nearest hundredth. Here we go. So it's saying to round to the nearest hundredth, which means I'm going to use the calculator to get that decimal. Just like we saw on that last example with the really ugly decimal, right? So on this one, remember the Pythagorean theorem. Here it is again, right there, right? So leg squared plus leg squared needs to equal the hypotenuse squared. We're solving for the hypotenuse. And remember, just in case you've forgotten, The legs are represented with the letters A and B, and the hypotenuse is represented with the letters C. Why not L's and H's? Well, L's kind of look like, lowercase L's looks like ones, and H's, I don't know why not, but whatever. So this one, of course, we can see, and I've purposely color-coded this so we understand that we are dealing with the two legs. How do we know that those are the two legs? Because there's the right angle right there. Remember, the legs make up the right angle. So these two values, and it doesn't matter which order you put them in, a leg is a leg. So the first leg, I'm just going to put 14 first, and then the 10 second. Now this means that if we squared these and then added those squares, then we end up with the hypotenuse as a square as well. And there's an interesting proof on that. My understanding is it came from President Garfield. Whatever your political affiliation, I don't really care. Not that most people know who President Garfield is, but he's dead too. In any case, but most of those guys are dead too. So in any case, so I'm going to go on my calculator, right? And I'm going to do this part by part. So you could say you're just going to do 14 squared plus 10 squared in the calculator, but I want to see this stuff, okay? So 14 to the power of 2 is 196, and then 10 to the power of 2 is just 10 times 10, it's 100. So of course, if you were to add these two together, you'd get 296, okay? So 296 needs to equal C, our hypotenuse, to the power of 2, okay? Now, like we saw, well, I guess we didn't see anything like this in the last section, but we've seen equations like this to solve. You just need to square root both sides like this, okay? So what, and this, see the square root and the exponent 2 right there, that they're going to undo each other, which leaves me with just a C value. So in my calculator, I go to the square root of 296, enter. Now it gives me 2 square root of 74, but it said it wanted the decimal to the nearest hundredth. That's the second decimal place. So I'm going to push the double arrow button just above enter, and it will change that into a decimal for me. So the decimal it's showing me is 17.2046. I don't really need the 6 either, right? Because we just want the hundredths, which is the second decimal place. And this 4 is less than 5, which means that the 0 will stay as 0. We don't need to add 1 to it. I know some of you just write that as 17.2, and that should work, okay? Which means the hypotenuse rounded, and, you know, depending on how big the project is, I'm thinking of construction, by the way, but, you know, whatever you're doing, you really need hundredths or thousandths, because you could go as many decimal places you need to for further accuracy on this hypotenuse, but there's a point where it becomes kind of obsolete, so there's some significant figures on this one. Not that I think you care, though.